So we've seen this wonderful chart online. Okay, so we do absolute values, we graph absolute values, we graph quadratics, we graph polynomials or odd and even functions, we graph radicals. Okay, we saw this. So now we're applying it to sine and cosine. It is slightly different. Okay, because sine is periodic, whether or not. Okay. But I have similarities as well. So let me see. I have to scroll this down. Oh, I can't scroll it down. Well, this still with the negative and positive. So negative A, remember, reflects. Across the x-axis. I'd write it up here, but it won't let me. So, in a box like this, it won't let me write in there right now. It's, I don't know. The A in this, we talk in with stretch and shrink. Okay, and you can technically say this is a stretch and a shrink vertical line. Okay, or it's the amplitude. What we've been talking about for sine and cosine is the amplitude. So this is the amplitude. It's the distance from the midline. Now when we graphed sine and cosine before, the midline was always at 0. Now it's going to change. Now we're going to shift it up and down, so the midline will do changing, depending on what the k value is. So the midline is going to be what the k value is. Now, any questions on that? Okay, the b value, we talked about that being the frequency. Okay. Frequency is the number of curves between 0 and 2 pi, how many times you have a sine curve or cosine curve. Okay. It kind of is also like a horizontal stretch. Okay. If I took the ends of my sine curve and my cosine curve and stretched it vertically, that's what it looks like. Okay, but we're still referring to as frequency. The h is the same thing it's always been. Okay. Negative h moves to the right. Positive h is to the left. The k value, positive k, moves up, and negative k moves down. Any questions over that? We're all good? So the first thing we're doing is graphing transformation is do any values done. Okay, I'm going to start by finding the period and the amplitude. Which is 2 pi over b for sine and cosine. Remember for tangent it's pi over b, but we're doing only going to go with sine and cosine today. So this is my b value. So the period is 2 pi divided by 2, which just equals pi. So in the past we put the pi at the end, but we're not going to do it this time because we're going to shift this. So it's not going to end at pi now because we have to shift it right and left. Okay? But we still have to count by. So to learn the x-axis, you're going to take the period and divide it by 4. So we have pi divided by 4 is just pi over 4. Any questions over that? And so that's how I count by. I count by pi over 4s. So pi over 4 plus pi over 4 is 2 pi over 4, or pi over 2. And 2 pi over 4 plus another pi over 4 is 3 pi over 4. This would be pi, 4 pi over 4. Then I add another 4 pi, or pi over 4. So 4 pi over 4 plus another pi over 4 is 5 pi over 4. Again, I'm not going to stop at the period this time because I'm going to shift my graph left and right. So I kind of want to model it all the way to the end. Any questions over that? Okay. We then go with the amplitude. Okay, so we count 1, 2, 3, and -1, -2, -3, and we should probably do -4, and +4 as well. With sine and cosine, it's a little different. If this was a quadratic, an x squared, okay, we would talk about the vertex. We would find the vertex of this, okay? We're still going to find that point, it's just not going to be a vertex now. So what would be our vertex if this was a quadratic? Anyone have an idea? Yep. Very good. Pi over 2, remember, this is the twilight zone. And then the 1 is the same. So pi over 2 and 1. This is what we call now a new origin. No, remember twilight zone. Inside the parentheses is the opposite of what we think, so it's a positive. Just like inside the radical, all that stuff is different. Okay. That's going to be the origin. So we're going to create a new x and y. So this is the original origin at 0, 0. We're going to create a new x and y axis at pi over 2 and 1. So at pi over 2, we're going to draw an x-axis, a new x-axis. And at 1, we're going to draw a new y-axis. Okay. This makes it a little easier to graph. Okay? So this is like our new 0, 0. So let's review where the signs start. At 0. Cosine starts at the amplitude, sine starts at 0. So sine is going to start right here. Then, from that point, we're going to go up to the amplitude. So this is 3, so from this point, we're going to move up 3. 1, 2, 3 is going to be my next point. Then it goes back to 0, the pattern of sine. Then it goes to the negative amplitude, so we're going to go down 1, 2, 3. I'm going to draw that in as well. So this is my amplitude. And this is the negative amplitude. Since I can't complete this because I'm on my graph, I'm going to go backwards. So from here, this would go down to the negative amplitude, then back up to the 0. And then this is my sine curve. Any questions over that? All good? Okay. Next one. Same steps. You want to find the period. So the period is going to be 2 pi over pi, which equals 2. Any questions over that? So what's going to be what am I going to count by then? A half. Okay. We take the 2. We divide it by 4. That gives me a half. So I count by halves. 1/2 plus 1/2 is a whole. Then plus a half is 1.5. Then we have 2. Then we have 2.5. Then we have amplitude, which is 1, but because it's negative, this is going to reflect. Any questions over that? So we're going to just count by 1s for the amplitude then. Any questions over that? Okay. Then we have a new origin. Joseph, what's my new origin? +2 and -3. Very good. 2 and -3. This is again the twilight zone. It changes to a positive. Okay, so we got our x and y axis at 2 for x. So that's my new x-axis, or y-axis. Oopsie, I'm doing that wrong. My new x-axis is at 2, yes. Okay, sorry. And my new y-axis is at -3. Any questions over that? So my y-axis is here, x-axis. And then we graph it. Okay. This is still same, so it still starts with the origin. Okay. Because it's reflecting across the x-axis, we go down to the negative amplitude. So we're going to go down here first. We can't go up there, so we'll have to go backwards. So from here, this would go up to the positive amplitude, down to 0, down to the negative, back up to 0. Any questions over that? And then this would be my new transformed sine curve. Yes. Negative reflects across the x-axis. It's positive. So here I have my origin. But my new origin is where we look at it, not the old one. My new origin is where I look at. Yeah. That's the amplitude. I'm showing you I have to go down one first. Okay. And again, I'm going down for my new x and y axis. Okay. Any questions over that? We're all good? Okay. I want us to do one for homework now. So let's get on our homework. Okay, so let's do this one and see how we did. Now, what is appearing? 2 pi. Justin, on the camera.
5/2.
Pi over 2, then pi, then 3 pi over 2, then 2 pi, skip 3 pi, okay, skip 4 pi. Then class, what's the amplitude? So 1, 2, 3 we're counting by. 1's for the y-axis, -1, -2, -3, and -4. Can you tell me origin?
5 over 2 and -1.
Okay. So we need to our new x and y axis. Oopsie, let's do a different color. Let's do the green. So my new y-axis is at pi over 2, and my new x-axis is at -1. Okay, then we start at the new origin at 0. Yes. Yes. Yes, at the end, when we're not transforming it. Okay? When we're transforming it, we can't necessarily say 2 pi at the end because we might have to go further. Does that make sense? Yeah. 3 pi over 2. Yeah, it's hard for me to write it in small enough to write it in, so I just, that's fine. Yes, and that's fine too. I would say you might get in trouble at some points depending on how far you shift it. Okay. Yeah. So that's the only thing if you're skipping lines at times, when you have to transform it might be a little bit, you have to go backwards more than you can go forward. Does it make sense? Okay. Then we're going to go up the amplitude. From here, we need to go up to 1, 2. This should be 2. From the new x-axis. Then you're going to go back to the origin, then down 2. Then back to the origin, over 0, and then up to the amplitude. And then this would be your pattern. So this is my new sine curve. Any questions over that? Yes. So we're not going to 2 here. You're going 2 away from your new x-axis. Because the amplitude is technically the distance from the midline, and this is your new midline. Yes. I do. If you stop technically here, that's 1 sine curve, and that's fine. Just complete a sine curve for sure, and then I'm just going to keep going because it's easy. Yeah.
What if we do the points like where
Yes. Well, you should be going to halves. So you need to have 1/2 and 0, and then pi and 1. And then 3 over 2 pi and 0, and then 2 pi should be at -1. These order pairs should exist. 2 pi, -1. That's an order pair that your graph should have. Does that make sense? Any other questions over that? We're all good? Okay. let's go back and do cosine now. So all those steps for graphing cosine are the same as sine. The only difference is the pattern you're graphing it is going to be different. So we're going to start the period, which is 2 pi over b. So we're going to have 2 pi over 3. Any questions over that? Then we get 2 pi over 3 divided by 4 equals 2 pi over 3 times the reciprocal of 4 is 1/4, 1 over 4. So that's going to give me 2 pi over 12, which is pi over 6. Any questions on how I got that? We're all good? Okay. So I'm going to count pi over 6's. Pi over 6, and then 2 pi over 6 is pi over 3, and then 3 pi over 6 is pi over 2, and then 4 pi over 6 is 2 pi over 3, and then 5 pi over 6. Then we're doing. Okay? You might need to write down, if this was rough for you following along, you might have to write down this is pi over 6, this is 2 pi over 6, and then reduce it below it. That's fine. Okay? I've just done this a few times now, so I'm good with my fractions. Okay. Then I need to know about amplitude. Class, what's the amplitude? 0.5. So that means I should probably count by 0.5s. 0.5 and then 1, 0.5 and then, sorry, negative 0.5 and then negative 1, negative 2, skip a line, negative 3. Then we need our new origin. Rebecca, what is that? New origin? Ooh. Pi over 3 and negative 2. Any questions over that? Okay, so we're at pi over 3. Draw in your new axis. And at negative 2, draw on your new axis. Okay, we're graphing cosine now, yes? Okay, so in your homework there's a one that is at pi over 4. So, yeah, so you can go in between it. So if you skip lines, that'll be perfect. That'll work, okay? I tried to make it so it's not crazy. Like you're not counting by halves and have to try and graph a pi over 3, because that's too, you can't. That's, yes, it can get crazy sometimes. I try to avoid those in your homework and in your notes. Because if that's the case, then we just use a graphing calculator. You don't want to do it like we're doing. Okay? Any other questions? Okay. So we have to remember the pattern of cosine. So where does cosine start at? At the amplitude. Now again, remember this is our new x-axis. So from here, where is our amplitude? At 0.5. From here, we're at 0.5. So this is my new point. So from here, I go up 0.5. I'm sorry?
You don't start in the middle and not the other ones?
At 0, sine starts at 0, 0. Okay, cosine starts at the amplitude. So 0 for x and the amplitude for y. Then it goes down to 0. Then it goes to the negative amplitude. Then it goes back to 0. That's going backwards. I have to do this. And then this. Just make sure this right here is your amplitude of 0.5. Okay, so this is my curve. Any questions over that? We're all good? Okay. Next one. Rika, what's the period here? 2 pi. Then we're going to divide that by 4 to see what we're going to count by, which is pi over 2. So this is going to be pi over 2, then pi, then 3 pi over 2, then 2 pi, then 2.5 pi, so that's okay. 3 pi over 2, 4 pi over 2, 5 pi over 2. Then our amplitude. Class, what's the amplitude? Okay, it's 1, but it reflects, right? So when it starts at negative amplitude. Okay. Here is my new origin. Negative pi over 2 and 2. So this is going to be negative pi over 2, since we're counting by pi over 2. Does that make sense? So this is my new y-axis, and that 2, oh, I'm going to count by my amplitude. 1, 2, 3, 4, 5, 6, negative 1, negative 2. So we're at 2. Okay, so this is my new origin, so I'm going to start the negative amplitude. So I'm going to go down the line and start here for cosine. Then we'll go back up to 0 on my new one, up to the positive amplitude, down back to 0, down to the negative amplitude. I'm just going to keep going because I have room. And this is my curve. It's missed it. Any questions over that? We're good? Okay, how do you guys start working on your homework then? Thank you. I'm going to have to explain how I describe the transformation. Sorry, I forgot about that. Flip it over. Yeah. distributions again throughout the whole year. This one's a little slightly different because of the sine and cosine. You're still going to say that the negative means it reflects across the x-axis. The change in phase amplitude. The three. The three is the period, or sorry, the frequency. We're going to use it to find the period. Okay, which is 2 pi over 3 then. The 3 also is that horizontal stretch. Okay, you're stretching the trig function horizontally. Then the pi is to the left, like it always is. Inside the parentheses is the twilight zone, so left pi. And then the negative 1 is down 1. Any questions over that? So here we have the amplitude at 1/2. Sophia B, what is your period? Since there's 1 there, it's just 2 pi. So you see, what would the pi over 3 mean? Very good, right. Pi over 3. And finally, class, what's the 5 mean? 5. Any questions on that? Okay, now you can start again your homework. Yes?